It's really easy, but I kind of flew through this stuff, and I just want to make sure you understand what the deal is. So I'm looking at homework 2.2, and it says, I'm just going to look at problem number 1. That's all I'm going to look at. But it says, are the following power functions? So let's start with that. Remember what a power function is. A power function is when you have x to a power, okay? And sometimes you don't physically see the power. So for example, in A, you see the power. So yes, that's x squared, yes. But B is also a power function because a square root is a 1/2 power. Remember, fractional exponents are radicals. So anytime you have a radical, you actually have a fractional exponent. So that's a power function. C is not, because x is the exponent. That's an exponential. That is not a power function. C is not. D is, because when you put an x in the denominator, what's your exponent? Negative something, right? In this case, -1. So even though you don't physically see a power, that is a power function. All right, now what kind are they? Well, these are your BFFs. What's A? A is a quadratic or squaring, whichever word you want to use. What's B? Square root. C is out. D, what's D? It's a reciprocal function. It's the reciprocal function times 7, right? 7 times 1 over x. So its coefficient, or its constant, is 7. That's D. What about B? B's constant is also 7, and A's is -2. So those are really easy exercises, but you do have to remember that power functions are anything with x to a power, but sometimes you don't see the power. Sometimes you have to remember that radicals are actually fractional exponents, and anytime you have something in the denominator, it's actually a negative exponent. Okay? All right, well, we can put that away. You can finish that up, or maybe you already have it done, or maybe you'll finish it during lunch. It's due tomorrow. Now I need you to get your calculators out real quick. We're just going to do a very basic exploration, and maybe you've already done this in another class, I don't know, but we're going to do it together. So first thing I want you to do is set your window. We're on page 4 of your notes. We're on page 4 of our notes, and we are doing problem 1 for 2.3. It says examine it. All right, so go to window, and let's just use a standard window. So remember, you can either hit zoom 6, that will always give you the standard window, or you can physically type in the -10 to 10. The standard window is when x min is -10, y max, or x max is 10, and the same with the y's. Okay, so zoom 6 will do that for you, or type them in. So now we have a standard window. Now, let's type in our equation there in A. Go ahead and type it in with the parentheses. You do not need to multiply it out. Thank goodness. You don't want to multiply it out, actually. It's easier when it's not. Then hit graph. Now, did you expect this thing to start down and end up? After our conversation yesterday, did you expect that to happen? Yes, because it's an x cubed. And it looks something like this. Notice it crosses the x-axis, or it has zeros at -3, -1, and 2. Is that significant in terms of the equation? Oh yeah, right? The zeros are coming straight from the factors of the problem. In a minute, we're going to sketch this without our calculator, but first we got to make a couple of observations. All right, so that looks okay for A. All right, let's try B. So just type in the new equation. This time we have a squared parentheses, and we're wondering what impact that is going to have on our equation. Does it have the same basic shape? Of course it does. It's a cube. That's what cubes look like. Now, if you have just x cubed, no numbers thrown in there, then you know what that looks like. That's your BFF. But as soon as you start putting in other numbers, then it increases the curvature. So tell me something now. This one only touched the x-axis twice. That makes sense. There's only two factors. Factors give us the x-intercepts. So if you only have two factors, you're only going to have two x-intercepts. But what was different about the behavior at this x-intercept and the behavior at this x-intercept? This one bounced off, didn't it? And it bounced off. What's that little shape look like? It's not, but what does that look like right there? A parabola? So when you have something squared, it behaves like a parabola. It has a vertex. It bounces back up. Anytime you have a squared factor in your problem, that's the way it's going to behave. Okay? Now let's look at the last one. Now we have a cubed factor. I bet you can tell me what this looks like knowing what you already know. Do you know what x cubed looks like? Yes, it's one of your BFFs. What have you done here? 2 units to the right. When you have a cubed factor goes through the axis, just like the single factors do, goes through the axis, but it doesn't go straight through. See how this goes straight through and these all went straight through? It doesn't go straight through, it squiggles its way through. So single factors go right through the x-axis. Squared factors bounce off the x-axis, and cubed factors squiggle through. Okay, put the calculators away, because now you're going to do this without the calculator. This is pretty incredible. So when you're sitting around the dinner table tonight, you can show your parents this, because this is pretty darn impressive. You're going to sketch this big polynomial. With no calculator. All right, so we're going to stop and think about what we already know. It has 3 factors, right? So it's going to cross the x-axis in 3 places. Those 3 places are going to be -3, and I'm always going to label my points +2 and -1. If you were going to multiply this out, which you aren't, but if you were going to multiply it out, what degree would it be? What would be the biggest exponent? 4? All right, wait, this would be x to the 4th. That's an even number. What did we say yesterday about even degree? Starts up, ends up, right? So whatever this thing looks like, it starts up here and it comes down. Now when it gets to that x-intercept, what does it do? Well, look, that one came from this one, right? There's no power on it, so it's just going to go right through. Now at some point, and we don't know how low, that's a calculus or a calculator problem, so I'm not worried about it. At some point, it has to turn around and come back up. because all these points have to be connected. This is a polynomial, so they're all connected. Now, what's it going to do when it hits this one? It's going to bounce right back off because that one is squared. So it just turns right around, bounces back down. Now again, I don't know and don't care how far down it goes. It goes down and then it comes back up because it has to connect. Now what does it do when it gets to that one? It shoots right through. Now again, we don't know the high points and the low points. We don't care about all that. That's the general shape of the curve.
Why does it start up on the left side?
Because even degrees start up and end up, period. Anytime you have x to the fourth, that's how it's going to be.
But like when it's on like 1a, why doesn't it start down?
Well, because that's x cubed. It depends what the degree of the polynomial is.
Okay.
If it's x cubed, it starts down, ends up. That's what x cubes do. If it's x to the fourth, it starts up, ends up. Okay, we talked about that yesterday. That's why I put that even odd degree behavior there. Because you need to know that in order to sketch these things. All right, let's try the next one. Okay. Now, gotta be careful with this because there's a negative hanging around out there. See that? We're going to talk about that in a minute. Let's put our intercepts on. Every x gets a dot on the axis, on the x-axis. Okay? So I think you know this one is going to be at 3. And this one is going to be at -2. What about that one? Where is that dot going to go?
0.
At the origin. That's exactly right. That's going to go at the origin. If there's no number added or subtracted, it's the origin. It's like x minus 0. If those are the only dots, I got 3 x's in my problem, I have 3 dots. If I multiplied it all out though, what power would I have? If I FOILed it all out, this would be x to the what? 6th? 6th? Now that's even, right? Even starts up and ends up unless you put a negative in front of it. That turns it upside down, so now it's going to start down and end down. So now my curve is starting down here. It's going to come up and hit that. I got to look up at my problem. What does it do when it hits that? It bounces off. So we call it tangent 0. Bounces off. Now it's going to come up and hit that one. Remember, as you move left to right, your dots must be connected. All right, what's it do when it hits that one? That came from here.
Going through.
Goes right through. Comes down and hits this one. That one's a little bit tricky because what's it do there? Well, it goes through, but it goes through with a squiggle. So we're going to kind of exaggerate that so that you can actually see the squiggle happening there. They don't, if they have a cube on them, a 3 on them, they don't just go straight through like this one did. You got to put kind of a squiggle on it.
I'm confused how you know it goes through and bounces off.
That's the degree of the factor. So if there's a squared on the factor, that's a bounce off. If there's no squared on the factor, it just goes right through. If there's a cube on the factor, it squiggles through. Oh, shooty tooty. What's the deal with C? What's gonna make this one a little bit harder?
Not in any.
Yeah, it's not factored. Now, kids, wait a second. Didn't the factors make it easy? Because with the factors, I knew right where to put the x-intercepts, right where to put the dots. So this first thing you're going to have to do is find your factors. So you can't sketch this by hand unless you have your factors. So let's take a close look at it. And do you have any thoughts on finding factors for this? Ollie?
You can take out an x squared for the first part and like a minus one for the second.
Oh, so what's Ollie doing? He's doing what we call factoring by grouping. So one option is always look at your problem and see if it groups. This one does. He says we can take an x squared out of the first two. And then Ollie, what would I need to take out of the last two?
Minus 4.
Minus 4. And of course, if the problem factors by grouping, and if I've done it correctly, these parentheses will always match, right? So I have x plus 3. And then my leftover part is x squared minus 4. Tell me about that, x squared minus 4. That's the difference of squares. So I have x plus 3 and then x plus 2x minus 2. Now, as soon as you get it that far, do I have this lined up right, boys? I think I do. As soon as I get it that far, now it's easy. We have 3 dots. Remember, every x gives you a dot. So I'm going to have a dot at -3, and I'm saying dot, I mean x-intercept 0, -2, and positive 2. What's the degree of this thing?
3.
3. X cubes start down, end up. That's how they do. Think of x cubed, your BFF, starts down, ends up. So this thing's going to start down here. Nothing is squared, right? So I'm just going to go right through everything. So I go through, go through, go through. Wow, that's pretty easy. D. Oh, wait, D's kind of easy. Speaking of easy, what are we going to do with D? We can factor it for sure. So I might pull a -2 out first. And I'd have x squared minus 10x plus 9. Is that right? And then that actually just factors like this because it's just a squared. Minus 9 minus 1. So that one's only going to have 2 x-intercepts. One at 9. And one at 1. Okay, what's its degree? 2. 2 should start up and end up, but it's got a negative in front of it, so it'll start down and end down. Knowing what you know about x squareds, does that picture make sense? Heck yeah, that's just a parabola, right?
So, would there be like a problem where it won't factor out and we have to
Oh, well, yes. So let's just hang on. That's what this whole chapter is about, actually. All right, so let's try E. In fact, why don't you try E on your own? It doesn't look too bad. See if you can get E sketched. You're first going to have to factor it.
Hey, honestly, I'm just happy I can get into the building. I will not walk. Like, once I've been waiting for people to come up. They won't tell you.
Students like today, I really miss my basement home. We didn't have all this down there. Anybody have a question about that one? That's what, letter E? Anybody have a question about that? Looks okay? Easy enough. The key is get it factored. Remember your general rules about where your end behavior is and how to handle squared and cubed factors. It's easy. Alright? So let me look at F. Looks just like all the rest of them, but it's got a little star next to it. What's going on with F? It doesn't group. So I don't want to say it doesn't factor, because it does, but it doesn't factor using any of the techniques that we've talked about so far. So we're going to need a new technique for that. So before we do F and G, we're going to do a little bit of other background work, and then we're going to come back and get F and G. All right? So for now, F and G are on the back burner, and we're going on to number 3. Because we're going to practice a few other skills, and that will help us, hopefully, be able to handle F later on today. Hopefully we'll get to it. This is the lunch period, right?
Yeah.
So, yeah. Okay. All right, so let's try number 3. Write an equation of the cubic function with these zeros. All right, so we're skipping F and G temporarily. I promise we'll come back, because that's the heart and soul of this chapter. But we're doing number 3 now. So we have a cubic function whose zeros, that means the x-intercepts, are these. And we're going to write the equation. So in other words, we're working backwards. The one you just did, you knew the zeros were -6, 0, and 6. Didn't those come from your factors? So if we're working this backwards, what are the factors that would match up with those 3 zeros? Jacob?
X minus 3.
X minus root 3.
Okay, yeah.
And x plus root 3, and x minus 6. So I'm going backwards now. I know where the dots are on the x-axis. So in order to get these dots, I had to have had these factors. And sometimes I ask you to multiply it out, and sometimes I don't. This time I want you to multiply it out. So we're just going to start foiling, and I would definitely recommend you foil these 2 first, because you see what's going to happen when you multiply those? X squared plus root 3x minus root 3x minus 3. You just foil. So we end up with just x squared minus 3. That's all that we get when we FOIL those 2 together. So then we'll throw in the x minus 6 now, and we'll FOIL again. So x cubed minus 6x squared, whoops, minus 3x plus 18. And there is your polynomial, if I didn't make any mistakes. Is that okay with everybody? Now, the next one, I don't want you to multiply out because it's going to be too big, but I want to introduce or review a word in there. If you look at problem 4, it says we have a polynomial function and the zeros are 3 and -4 and 1, but 1 has multiplicity 3. What do you think that means? 1 has multiplicity 3. It means it happens 3 times. It's a cubic 0. Caleb, you feeling okay? All right, so my factors, I'm only going to have 3 distinct factors. X minus 3, x plus 4, x minus 1, but that one is going to have a cube on it. That simply means that factor occurs 3 times. Multiplicity means it's a multiple 0. And so whatever the multiplicity is, that's how many times it happens. Now there's one more piece of this that we need to be aware of, and that is there could be a coefficient out here in front, right? Because there are lots of polynomials that have those as zeros. Some of them go real high, some of them are upside down, some of them are fat. But at this point, I don't know what that is because they didn't give me any other points on the curve. In the future, if they give me an extra point on the curve, then I'll have to plug it in just like you did on your quiz and find out what that coefficient is. Right now I can't because I don't know enough information. All right, get your calculator back out. We're going to do a regression problem, number 5. We can do number 5 by hand, but we're not going to. We're going to let our calculator do it for us. So this is, anybody remember maybe some steps how we allow our calculator to take these points, which notice are not x-intercepts. These are just random points. And we are going to do a quartic regression on that. They remember how to do that? Well, Rory?
Then you go to the calc trace edit and then put them into the x and y values.
I've never done it that way. I don't know. Then what do you do after that?
And then plot it, quadratic regressions.
Oh, okay, you can plot it and then go into stat and do the regression, yeah. So I'm gonna just go ahead and try that, Rory, and see if it works. I'm gonna go ahead and just go to stat right from the get-go and just enter my data there. So I'll enter my x's as L1s and my y's. Oh, is that what you meant? Okay. Yeah. And I don't even need to plot this because I know it's going to be a quartic regression. So I'm just going to enter my data points. So go to stat and in L1 put 3, 4, 5, 6, and 8. And in L2 put -7, -4, -11, 8, and 3. And then go back to stat, calc, and go to quartic regression. And as always, it tells you the format of your equation. The format of your equation is going to look like this. And then it gives you all these values. And we'll have to round them off because they didn't come out nicely. Well, B did, I guess. all down, right? Did you get those numbers? And so then you just plug them in for your A, B, and C in your general format. I think I mentioned this the other day, but maybe I didn't, so let me mention it again. If you're going to do a regression like this, and the points are not special, they're just random points on the curve, whatever regression you're doing, you need one more point than that. So think about it like this. If you're writing the equation of a line, you need 2 points. And lines are x to the first, you need 2 points. If you're doing a squared, x squared, you need 3 points. If you're doing an x to the fourth, you need 5 points. You always need one more point than the degree that you're trying to find the equation for. Okay? All right, let me see if this is a good spot to stop. I believe it is a great spot to stop. So we'll stop now and have lunch. Turn the video off. We don't need the video lunch.